Okay, question number 10. So we have this sine of 3 theta equals sine of 2 theta. So I've got some double angle formulas, and these are the double angle formulas from the formula sheet. So for sine of 3 theta, I'd like to use the sine of x plus y, where x equals 2 theta and y equals theta. That'll give me a 3 theta. And for the sine of 2 theta, I'd like to use this. Okay, so sine of 2 theta plus theta equals the sine of 2 theta. So my right-hand side becomes 2 sine of theta cos of theta. And my left-hand side becomes sine of 2 theta times the cos of theta plus cos of 2 theta times the sine of theta. Since I've got sines and coses, replace my sine of 2 theta with 2 sine of theta times cos of theta times cos of theta. So that gives me a cos squared plus a double angle formula for the cos of 2 theta. Now I've got a few choices. I can use this one, or this one. Now since I've got a sine and a cos, and a sine and a cos, I'd like to choose the one that gives me a sine and a cos. And the way I'm going to do that is if I use this as my double angle formula, when I multiply it out, I'll have a sine and a cos. So that's going to be 2 cos squared theta minus 1 times the sine of theta minus 2 sine of theta cos of theta equals 0. I wish to make it equal to 0 so I can solve once I factorise. So 2 sine of theta cos squared theta plus 2 sine of theta cos squared theta. So that gives me 4 of them. Sine of theta cos squared thetas minus sine of theta, and then minus the sine of theta cos of theta, minus the sine of theta cos, minus, there's 2 of them, 2 sine of theta cos of thetas equals 0. I've got a common factor of sine, so sine of theta 4 cos squared theta minus 2 cos theta minus 1 equals 0. And if I was to make cos of theta equal to a, I've got 4a squared minus 2a minus 1. So a is going to equal 2 plus or minus the square root of 4 minus 4 times a, which is 4, times negative 1, all over 2 times a, which is 8. 2 plus or minus the square root of 20, all over 8. 2 plus or minus 2 root 5, all over 8, which is 1 plus or minus root 5 on 4. So a is the cos of theta. So from this factor, I get 2 answers. And from this factor, I get the sine of theta equals 0. So if the sine of theta equals 0, then it's going to be here or here, which means the cos of theta equals plus or minus 1. So I've got 4 solutions. I've got the cos of theta could equal plus or minus 1, or plus or minus 1 plus or minus root 5 all over 4. They're my 4 solutions for the cos of theta. So using double angle formulas and making the selection of this one, not this one, because I wanted to keep coses and sines so that when I took the one sine out as a common factor, I was then just left with cos. So that's question number 10.